Welcome everybody. Thanks for coming and listening to EPC project management in the renewable energy side, where myself coming from the large-scale projects from Siemens, now with Multicore Global Enviro in Singapore, where we have some subsidiaries as well around Southeast Asia, which I will introduce to you. The agenda for this short 20-25 minutes we have, I give a short introduction about Multicore that you understand why we are coming up with EPC and how can we actually do it. Then the key factors to make profitable EPC projects in renewable energy is quite important and not so easy actually. And then the Q&A at the end if there are some questions from your side. Multicore Global Enviro is a Singaporean company, and as you can see, already 40 years in business. However, they have been in trading, and what we build now as a subsidiary of Multicore Infracore Holding, we are doing renewable energy projects since 8 years. We started basically in Indonesia, coming over to Malaysia here, and maybe you have heard about Multicore from a Quascore point of view, where we have done the engine installations in numerous projects already. However, we have been developing ourselves further into EPC solutions, where we truly solve problems for clients and provide solutions in terms of power plants with their local supplies, especially Indonesia. I can imagine that, all the islands they have not everywhere just sources available. So some islands they have more coal, some islands they have maybe more biomass in order to produce their power. So Multicore, we have 40 years of experience. We have installed already 450 megawatt of electricity power plants. Is it just with the gensets only or full swing projects? And our scope is more in the small or medium range of power plants. So we go only up to 20, 30 megawatt in order to manage the projects properly. The bigger projects, we leave it to the big players like Alstom or Siemens or these contractors. We have subsidiaries. The one here in Malaysia, we are in Filho da Mansara with our office, and we just got a new office in Bangi where we have then space for the large-scale containerization as well for our engines. We have our Jakarta office where we build subsidiaries all over Indonesia now for supporting the clients with service at the local place where the engines or their power plants are standing. And we just went into Thailand as well to build Thailand. As you know, they have quite good outlooks in terms of feed-in tariffs and as well the green projects supported by the government. Why EPC? I'm coming into the points about EPC, but what Multicore understands under EPC is engineering, where preliminary design is quite a key factor in order to be successful in the projects. You will see what I mean later. Then the complete or detailed project planning, once we would have the contract signed in order to go into the details required to execute the project. Of course, the project management, where monitoring and controlling is a key factor to make the project successful. And what we offer then is long-term service agreements, and I think that's one of the key factors in green projects to not just build a power plant with renewable energies, but as well to maintain and service the power plant to make it work. And of course, the excellent after-sales service to have the right teams and the timely maintenance to make it work in terms of to enable the operation to be permanently there on site and run the engines. Depends on biogas or biomass or the boilers, whatever it is. Now, the EPC points I want to give you here. Of course, we can talk about these points much longer. So in this next 15 minutes, in order to understand EPC, we can say that now we are EPC because engineering, procurement, and the construction is a key factor in getting projects done successfully. What EPC really means is usually turnkey projects. That means the contractor doing an EPC project has the sole responsibility, including all risks of course, to make the project a success from the start to the beginning. But the problem is, we are talking about projects. Yes, everybody can do projects, that's easy. However, to make a project really workable, the engineering part is a key factor. And here, the beginning of the project, the front end engineering part, if this is wrong, actually you can do in construction or you can do project management as much you want, you will not get a proper result, or you pay a lot more money to make it work at the end. We have a lot of pitfalls for contractors, and that's for you. I'm not sure if you get at the end the slides for you as well to take away, but this is a checklist. If you have an EPC contractor at hand to actually check, do they have the right people at hand? Or did this company just grow out of nothing? Like the last 10 years, so many green companies grew out from nothing. So where is the substance to run EPC projects? I can tell you, to get done proper engineering, you really need the right people in order to talk about engineering and then the project planning and the completion of the project. I got my peers as well from the company. They know what I'm talking about. It's not so easy to build a team, isn't it, to make the right engineering. So, of course, a company, a small company, to run a show for a project, let's say 3-4 million US dollar. So can the company take as well the financial burden for providing performance bonds or having the working capital to run the show in the project? This is a key factor for being a successful EPC contractor. If the money is not there, most likely the project will be doomed. So, the timing still okay, huh? And of course, accounting, that's what we discussed. The management itself, the people, is the management supporting the EPC thought as well? Or is it just the management interested in making quick money? Usually EPC requires the complete, from the beginning towards the end, the complete management support in order to get the project done. I told you earlier, I'm coming from Siemens. And 10 years ago, when I entered into large-scale projects, what Siemens teach me that time is projects, because Siemens made a big learning 15 years ago throughout the world when they implement the project management. The bidding quality of the project is a key factor. If you make mistakes in your bid, forget the project. Respectively, the project is doomed or you spend a lot of money. Siemens can take it. A smaller company is maybe going into the ground. Contract management. I have seen many contracts, and believe me, the contract is a key factor as well to make the project run. So whatever you are bidding here and promising to the client, you better take care in the contract that you are protected as well. As an EPC contractor, if you use FIDIC, Silverbook for instance, then actually the risk is fully on the contractor itself. So, are you ready to take the risks? Have you actually done a risk analysis? And the qualified project manager. Usually companies, they have genius engineers. And then because they are good in engineering, oh, now you are running the project as well. However, they have never actually done one lesson of project management training or anything. So they now run a project maybe on EPC level, which they have never done before, and actually doesn't matter then whatever you're proposing here, if the project manager cannot run the show, your project is doomed again. And claim management. It's not only variation orders. Claim management is the regular money income on a monthly basis, ideally, in order to have positive cash flow in your projects. EPC projects, if you have the complete responsibility from the beginning to the end, and the project takes 12 months, I'm not sure how many companies actually can take the financial burden over 12 months without a single cent income, isn't it? So these are the 4 key factors to have in-house in order to run successful projects. Another topic, understand the complete project, the life cycle from the beginning until the end. Usually during the initiation phase, I'm using here initiation, planning, execution, closing. This is from PMI, the International Standard for Project Management, okay? So, if you have the initiation stage with salespeople, usually your salespeople, they sell anything outside, isn't it? However, the engineer may be not able then to finalize the project, whatever the sales has sold. Important for the very beginning here to actually understand at the end what you need to deliver. At the end of the project, we always go through testing, commissioning, and then the project closeout in order to run and operate the plant, correct? In order to get there, you need the proper setup at the very beginning already in order to make your project here a success. Any contract nowadays, at least for the government or the big part is out here, warranty and defect liability period is a given thing. In order to survive the 12 months of warranty usually, or 6 months or 24, depends on the size of the plant, it has to be factored in at the very beginning already in the project. If this is not included in the sales process, at the end, you cannot make your project a success. Once the initiation is done, the project is handed over, then we can go into the detailed planning. And of course, detailed planning means detailed design with all the shop drawings, everything required in order to make the project and go into the execution phase. During execution, what is missing here, and this is the key factor in project management, is monitoring and controlling. That's what a project manager, this person I mentioned before, has to do without fail. If the monitoring is not there, actually the project can go in any direction, isn't it? And usually EPC projects are bigger projects. Small projects, easy. Tomorrow I see, oh, something wrong, no problem. Big projects like EPC is like a heavy oil tanker. If an oil tanker is running in one direction, full of oil, if you turn the wheel, what happens? Oil tanker immediately turn around? Not really, isn't it? Oil tanker still goes many, many meters straight until you can control the direction of your oil tanker. So, in EPC projects, that's why it's very important to have a tedious monitoring on a regular basis during execution phase to finalize on time and hopefully on budget. So, now, many times underestimated in EPC projects is the engineering part with systems engineering here and the project management. There is a Dr. Fosberg from the US. He did this V diagram. That's a single V diagram. There are more complicated ones. Come up with this systems engineering diagram. And the key concept for you to take away, if you take away anything from here, this is the one you should remember. At the beginning here, you have the concept phase, the big idea, somebody coming to you, I want to build a power plant, I got some green grass out there, I want to burn it and make some electricity out of it. Nice, okay. The key part is, from this idea, at the very beginning, please ask how you want to operate and maintain it, because that's the key. That's where the money is at the end of the day, isn't it? So, once this is clear, how you want to operate and whatever you want to build, this is going into the contract. This is actually the basic concept, isn't it? Once you have the concept, then make it nail-proof here in the contract itself. Then the detail design, and then the test documentation. That's the key. In order, when you have executed the job, that it is clear for the client, what exactly do you get? Now I have two colors here. Blue, green. The red is execution. That's when you turn your designs into reality. But why you think is different here? This is the integration part, when you do the testing, the component testing, the integration, the certification, validation of your system. Any idea? Not yet? Good. So I give you the clue. If your design team here is doing the drawings, installation is installing all the components, and then the same team is doing the testing, of course I would not question my own design, isn't it? So, when I'm coming from, what we always do, separate the design team from the testing team to really make it fail-proof, that really the system is tested to the ground and understood in order to make it operational here. And another point, of course, from a contractual point of view, all the outputs with the site daily logs, the proper documentation in terms of checklists, to tick, 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 sign at the end, the documentation, test reports, everything signed, because at the end, if we hand over to the plant owner and they want to operate, we want at the end the proper, from the operational here, that the money as well from Keta, or not from Keta, from SEDA here, that's actually where this documentation plays a key role to certify your plant to make it operational and bankable at the end. So, now, to make your project bankable, whatever you heard before is the basic understanding you have to have in the project to bring this together for the points, the 8 bullet points here, to make your contract, your project bankable. It is, of course, easier between balance sheet and project financing. Balance sheet financing means your company is having a project and you have already turnover of 10 millions. So then the bank maybe say, okay, you have already some properties or office value. It's easier to get a financing from a bank because the bank has some security, isn't it? But if your company is brand new, green, coming out, and they need project financing just for a single project only, that's when the bank wants to see that the project is really feasible. So the feasibility study is really the factor which has to be in the full picture with the scope here, battery limits, and what the engineering diagram from before is showing you as well, the interfacing between different components. And to understand whatever you design, you have to certify as well, that the bank can see you have done your risk management very carefully, and from an engineering point of view, you know how to get your plant certified. That's the key part. Otherwise, bank will not give you money. Why? Then the PPAs. Nowadays, and especially in Indonesia, we face this problem to get the PPAs, the power purchase agreements. That's a key part, and it's not easy to get that. So, before you start the project, or even spend money for any groundbreaking or whatever, if the PPA is not signed, that means the PPA enables you, at the end, to operate the plant and sell maybe the electricity to the grid. So, if the PPA is not available for the bank will not give you the money. And don't underestimate the process which it takes. Is a TNB here with Malaysia, or SEDA, or then Indonesia as well, the same, in order to achieve the documentation, the approval, in order to have the agreement settled. And yeah, usually what the bank will say, if the PPA is, let's say, for 10 years, so your loan from the bank will not go 10 years, because there is a risk as well. If there is not enough, maybe operational revenue, that they say at least we have maybe 2 more years to collect revenues to actually cover the loan from the bank. And it should be easily calculable and identifiable with LDs in the contract. There must be EPC contractor involvement in the contract with some performance guarantees that the bank will accept to finance the project. So usually performance guarantees is between 5 to 15% of the whole contract, sum. And yeah, the performance bond, and then there is another performance guarantee that maybe even the shareholders of the company or the special purpose vehicle have to be involved in order to have a cost overrun bond. Let's say the EPC contractor fails in terms of engineering or design or the performance for the implementation itself, that the performance overrun then covers in case the client or the owner has to change the EPC contractor and has some money available in order to refund himself and the losses. So, and of course, at the end there is a warranty bond. Usually you can call it a warranty bond or retention bond. At the end of the project can be between 5 to 15% again, in order to cover the operational part of the power plant and make it a bit more secure as well for the bank that the EPC contractor is not running away. So, why I'm telling you all this, that's because Multicore learned that way and have implemented all this, and that's what we can offer now to the market in renewable energy projects and implement this successfully. I just give you some project references. I don't explain too much, but at least you see some substantial projects we have as well done with our boiler company in Surabaya, that we can do even steam power plants, some magnitude, yeah, that's the capacity we can do. Or this is our engine. Here we have the sole distributorship in Malaysia and Indonesia. Some installation, this is from the early years, all running. This one not running yet, we're waiting for the gas. So Multicore as well doing the scrubber systems for cleaning the gas, then go into the engines and connect it to the grid. So some more examples. This is maybe interesting. SciPark is around the corner as well. So we have even installed on their field the engines. Unfortunately, it is commissioned, but not enough gas to run permanently. However, the system is running even with the landfill gas. It's working. So, is there any question? Good. If not, or maybe you wish to have maybe a one-to-one discussion and challenge me there, then we would be at our booth and would be a pleasure to meet you again. Thank you.